behaves. Most AI agent demos are built around the happy path. The input is clean, the API works, the tool returns the right data, the agent reads, the result writes a confident response, and the demo looks impressive. But production does not behave like that. It behaves. Production is where the asset owner is missing, the threat intel API times out, the ticketing automation behaves, the system accepts a draft but fails assignment, and the model sounds confident even though the evidence is weak. That is where agent design actually starts and behaves. Every agent is not defined by what it does when everything works. It is defined by what when something fails. If an AI agent is going to operate inside a security workflow, you have to design the failure modes before you trust the action. So it behaves. A failure mode is a predictable way the system can break, degrade, or make the wrong decision. That does not always mean a dramatic crash. Most failures are boring. Missing data, stale records, ambiguous ownership, timeout errors, low confidence, conflicting policies. Those boring failures matter because an agent sits between information and action. A chatbot can give a bad answer and the human may catch it. An agent can create tickets, root work, change priorities, update records, or prepare approvals. So when the agent is wrong, the mistake can move downstream into the workflow. That is why the goal is not just to make the model sound smarter. The goal is to make the system fail free. Let us use a vulnerability management agent as the example. Behave, the scanner finds a critical issue on a VPN gateway, a high severity issue on an internal application, and a medium severity library problem on a finance workstation. Automation behaves on the happy path and enriches each finding with asset inventory, threat intelligence, ownership, maintenance, windows, and policy. Automates then it deduplicates the findings, ranks the queue, drafts tickets, and prepares approval packets. Useful. Now let us make the workflow realistic. The VPN gateway has an asset record, but the owner field is blank. The internal application automation days has not checked in for 42 days, so the inventory may be stale. The threat intelligence lookup times. The ticketing system accepts a draft ticket, but assignment fails, and the approval policy says production remediation requires a human approval step. A weak agent design hides those problems by confident language. It behaves. It might say the VPN gateway is owned by network operations because that sounds likely. How the automation behaves might treat the threat intel timeout as if no exploitation exists. It might create duplicate tickets because automation behave does not recognize that several findings point to the same service. Automate behaves. It might recommend immediate patching without noticing the approval boundary. Behaves. That is not autonomy. That is unmanaged risk with a nicer interface. A stronger agent design treats failure modes as first-class workflow states. Behaves. If the owner is missing, the agent should mark ownership as unknown. It should not invent a person. Behaves or team. Automation behaves can search allowed sources, look for recent tickets, or identify likely owner candidates, but those should be labeled as suggestions, not facts. If asset inventory has stayed, the agent should reduce confidence. Automation behaves. It should say the record has not checked in recently, so priority may need review. It can still automation behaves, prepare the packet, but it should not pretend the context is current. Automation behave. If a threat intelligence times out, the agent should not convert that into good news. Response from a tool is not the same as no known exploitation. The correct state is enrichment. The automation behaves. If ticket assignment fails, the agent should preserve the draft, capture the error, and create a review item. And how the automation behaves should not silently drop the task or tell the user everything completed. And if the next step requires approval, the agent should stop. That pause is not a weakness. That pause is the control system working. Automate behaves. The pattern is simple. They continue the safe parts, stop at the risky parts, and make uncertainty visible. Behave. This is where a lot of agent projects go wrong. They think autonomy means the agent should push through every obstacle. Production autonomy is not about forcing action. It is about knowing which actions are safe, which actions are blocked, and which actions need human judgment. That means every agent needs a permission map. Behave. The permission map defines what the agent can do automatically, what it can prepare but not execute, and must escalate. Automation, for example, the agent may be allowed to create a draft ticket automatically. It may be allowed to assign a low-risk workstation patch to the endpoint queue. Automation behaves, but it may be allowed to prove a production change, suppress a critical finding, or route urgent. Automation behaves where inferred owner as if that owner were confirmed. The second design layer is observability. Automation behaves if the agent makes a recommendation, the team should be able to inspect why, what data did it read, which tool calls succeeded, which calls failed, which findings were grouped together, fields were missing, which policy rule forced to stop. Without that evidence chain, the agent becomes a black box, and black boxes do not earn trust in security operations. Automation behaves. A good agent should leave a clear reviewable record. Funding IDs, asset IDs, owner status, exposure state, threat intel status, ticketing status, approval rule, recommended next action, non-certainty. This is how a human reviewer can say yes, no, or not yet. The hood design layer is Retry behavior. When a tool fails, the agent needs rules. How the Retry one should it wait? Should it use a fallback source? Should it stop and ask? Automation behaves. Should it continue with lower confidence? Do not leave that to vibes. Auto behaves. A threat intelligence time it may deserve a Retry and then a blocked enrichment state. Automation behaves. A ticketing assignment error may deserve preserving the draft and creating a manual assignment task. Always a missing owner may deserve a lookup in the CMDB recent ticket history and application registry, but not the answer. Every retry rule should have a limit. The automation behaves. The agent can loop forever spam tools, create duplicates, or burn time without moving the workflow forward. The fourth design layer is requeues. A review queue is where the agent sends work it cannot safely finish. Automation behaves. If the agent does not know what to do with uncertainty, it will either hide it, ignore it, turn it into fake confidence. A review queue gives uncertainty a place to go. The vulnerability workflow, the queue might include owner missing, asset inventory stale, threat intel incomplete, approval required, behaves in duplicate match, uncertain ticket, assignment failed, or remediation window unclear. Each review item should have a clear reason and a clear next action, not just agent failed. Automation behaves better, asset owner missing, candidate owners found in recent ticks, but no confirmed owner in inventory, human review required before urgent ticket assignment. Gives the team a decision. The automation behaves. This is the difference between a brittle agent and a production ready agent. A brittle agent assumes the world matches the demo, behaves. A production ready agent assumes the world is messy, then designs safe behavior for the mess. Automation behaves. Before you ask how much this agent can automate, ask a better question. What happens when the data is missing? What happens when the tool fails? What happens when the model is uncertain? What happens when the policy says stop? Automation behaves. If you cannot answer those questions, the agent is not ready for production action yet. How the automation agents will not be the ones that never fail. Automation behaves. They will be the ones that fail clearly, safely, and recoverably. Perfect autonomy, controlled autonomy, not blind confidence, reviewable evidence. Patient, not action at all costs. Safe progress with clear stop points. Automate behaves. If you're building AI agents for cybersecurity, start there. Design the failure modes first, then decide how much action the agent has earned.